Good morning, dear students. In this class, I am going to discuss analysis of some algorithms, some sorting algorithms. In the last two classes, in the first class, I have discussed about the introductions of algorithm, what is algorithm, what is analysis of algorithm, why we need the algorithms, why we are not directly writing the program, and why analysis of algorithm is required. And in the second class, I have discussed the asymptotic notations, different type of notations to represent the cost of an algorithm. And there also we have discussed about RAM model of analysis of the algorithm, and also Turing machine model of analysis of the algorithm, or finding the time or space complexity of an algorithm. And in that class also we have discussed the time complexity and space complexity of the algorithm, and also we have discussed about big notations, theta notations, and omega notations. Okay. Now in this class, this is the third class, and in this class I am going to discuss about analysis of some of the sorting algorithms, As I have told, analysis of an algorithm is nothing but finding the resources required by the algorithm. Resource may be the time required to complete the algorithm, may be the space, that are the memory requirement to complete the algorithm. But in this class we will focus basically on the time complexity, not the space complexity of the algorithm. Hence, in the analysis of algorithm, whatever the 2-3 algorithm, sorting algorithm we will discuss in this class is all about the time complexity of the algorithm we will calculate. Now let us consider a simple sorting algorithm problem. So sorting problem. Now, as we know, in the sorting problem, a sequence of n numbers is given, and they are represented by a1, a2 up to an. And what will be the output? The output is give us output is to arrange the numbers in this case is the ascending order. That means arrange the numbers a1, a2, a3 such that a1 is less than a2, is less than a3. This is the problem statement. Problem statement means we have n numbers, and what will be the output? The output is the arranging of the number in ascending order. Now, this kind of problem we call it as sorting problem. Now, there are different, as you already know in your data structure, there are different sorting algorithms. Now, these sorting algorithms we are now going to discuss, and their time complexity. In this class we will calculate the time complexity analysis of these algorithms in terms of time complexity analysis. Okay. Now, let us consider the solution of this problem is by the help of a particular type of algorithm called insertion sort. Insertion sort. What does it mean by insertion sort? As you students might have played the playing cards. In the playing cards, what happens? How you sort the playing cards? In your hand, initially your hand was empty, and you are bringing one card and you are putting. Then you are taking next card, and you are seeing where the card will be placed. That means where the card will be inserted, so that it will be in its proper position. Accordingly, you are shifting the card and inserting. That method is called sorting is called insertion sort. This method is called insertion sort. Let us see in the example. See, you have these cards 6, 10, 25, 36. They are in your hand and they are sorted. Now you are taking another card 12 and you have to put it in its proper position. The position of 12 is in between 10 and 24. Hence, how will see, how will insert it? That means first of all you will compare it with the 36 and 36 is greater than, hence you have to shift it. Then again you have to compare with the 24, whether 24 is less or 12 is less, 12 is less, hence again what happened, 24 will be shifted. Now you will compare it with again 12 with 10, okay, 10 is less, 12 is not less, hence you have to insert it. And this way of sorting, you see, you have inserted it and inserted, then now 6, 10, 12, 24, 36. This way of inserting this way of sorting the element is called insertion sort. Now take some bigger example of an input array. This is the input array. Now you want to sort it using insertion sort. And first of all you will consider the first element, the element 5, and this element 5 is in your hand, and this element 5 is by default sorted, because this is, if you consider a single element, it is by default sorted. Now the 5 is sorted. Again you want to consider the two elements 5 and 2. Now in this case, and the 2, 5, 2 is not sorted, that means you are taking the new element 2, hence what happens, you have to shift 5 towards right and insert 2 in its proper position. Now here 2, 5 element is left sub array is sorted. Now you consider the number 4, and in number 4 what happens, you see 2, 5 is sorted and you have to insert 4 in its proper position. Since what will happen, you have to shift 5 one position right, because 5 is bigger than 4, and again 2 is less than 4, 4 is bigger, hence in between 2 and 5 you have to insert 4. See, this is 2, 5, this, then 4 will be inserted in 5. Now you are considering 2, 4, 5 is a sorted element. Now you are considering the next element, which value is 6. Now 6 is greater than 5 and no need to shift, its position will be itself. Hence 2, 4, 5, 6 is now sorted. Now you will consider the element 1. Now you see 1 and 6, you will compare. 1 is less than 6, hence you shift 6. Then you compare with 5. 1 is, what is less than 5, you shift 5. Then you compare with 4. 4 is less than 1, then you shift 4. You compare 2. 2 is less than 1, you shift 2 and you insert 1. That means, and similarly in case of 3, 6 is greater than 3, hence you shift 6. 5 is greater than 3, you shift 5. 4 is greater than 3, you shift 4. Now you are finding an empty position, there you are inserting 3. And this method of sorting is called insertion sort. Why you are saying it as insertion sort? Because in an already sorted array, you are taking a new element and you are putting it in its position such that the new array, which is the old array, sorted array, and the new element, the whole will be sorted. Hence, in this case, we call it as insertion sort, because we are inserting the element in its position such that the new array element will be sorted. Now, what will be the algorithm? If you write, if this is the way of sorting insertion sort, then you have to write the algorithm for it. Suppose you are writing a method to sort this way, and this way of sorting is called insertion sort, and for that we have to write the algorithm. How will you write the algorithm? See, this is the case, it is happening as I have already explained. 2, 5 we are exchanging, then 4 is coming, then 4, 5, 4 we are exchanging, and then 6 is coming, it is not exchanging, then 1 is coming, then 1 is going to 5, then 5, like this it is sorted. Now you see insertion sort. How it is happening, the insertion sort? Because in insertion sort, the first element is of the first sub-array. The array, sub-array consists of first one element is by default sorted. Hence, the sorting will start from considering the second element onwards, second element up to the nth element. Hence, in this insertion sort, for j is equal to 2 to n. Why we are writing j is equal to 2 to n? Because j is equal to 1. That means considering the sub-array consists of only one element, that means it is by default sorted. Hence, the sorting procedure will start only when the number of elements in the sub-array is more than 1. That's why for j is equal to 2, 2n, that means the j is equal to 1 means one element in the sub-array, that means it is by default sorted. Taking j is equal to 2 means we are considering the second element, that means in this sub-array we have 2 elements. The first element is by default sorted and we are considering second element. In this way, while the sub-array will be n element, that means we have considered all the n elements and we are trying to sort it. Now, what we will do? Now we will consider the key element as aj. For j is equal to 1 to n, that means key element is equal to aj. That means j is equal to 2 means the second element we are going to sort it and we will insert it in its proper position. For j is equal to 3 means the third element is our key and we want to place it in its proper position in the remaining sub-array having 2 elements. Like this we will do. Hence, insert aj into the sorted sequence a from 1 to j minus 1. This is the, as I have already told, this is the procedure of sorting. Now, what will happen? In order to place the key element aj in its previous sorted sequence, that means a1 to j minus 1, what will happen? We have to compare from aj minus 1 to a1 individually. That means, in this case, I will be j minus 1 because its previous element has to be compared and according to whether greater than or less than, accordingly it will be shifted. That means it will terminate while all the elements, previous element we have up to the last element we have considered. That's why while I is greater than 0, if I is equal to I is greater than 0 and ai is greater than key, if ai, because it is already setted, if ai is greater than key, that means last that means the element, last element in the sub-array which is bigger than the key, up to that we have considered the comparison. Hence, do ai plus 1 is equal to ai. That means here what happened? We are shifting the element. See, if this while condition is satisfying, that means my key element, my key element, if this is satisfying, my key element is bigger than the ai element and there is still an element remaining in the array. Okay, this is the while condition. While I is equal to 0 means there is still an element in the sub-array, sorted sub-array. ai is greater than key means the sorted sub-array element for that particular I is, if this condition is satisfying, that means ai is less, ai is greater than key, ai is greater than, that means key is less than ai, that means the ai element will be shifted towards right. That's why the ai element is going towards right, that means ai plus 1 and I will be I minus 1. Hence, at the end what happens? The key will be get its proper position and it will be ai plus 1 will be key. Okay, now for the same example we will consider this. In this case we will consider this. See, in this case I is equal to your, in this case what will happen? J will be from 2 to 6. You see the algorithm, here. J is equal to 2 to n. Hence, in this case, J will be 2 to 6. J will be 2 to 6. And while J will be 2 to 6, first of all, J will be 2. If J will be 2, the key element will be, you see, the key element, do key is equal to Aj. That means your key element will be 2 and your I value will be J minus 1. Hence, I value will be 1. I value will be 1. Now, you see, I value will be j minus 1 means 1. Now, while I is greater than 0, because I is 1 in this example, hence it is true, and ai is greater than key. You see, ai is your 5 and key is 2. Hence what will happen? Your ai is greater than key because ai is your 5 and key is your 2. ai is your 5, key is your 2. Hence what happens? What will happen? ai plus 1 is equal to ai. That means ai plus 1. That means here what happens? Your 5 will take the 2 position. 5 will be shifted towards right. And after that what happens? I will be I minus 1. Since now I will be 0, hence the while loop will terminate and ai plus 1. Because I will be 0, I plus 1. I plus 1, that means I plus 1 is equal to 1, then 1 will be key. That means in this I1, 2 will be placed, and that means 2, 5 will be in the sorted. Similarly, now j will be 3. Now once j will be 3, according to this, again the outer for loop will on, j will be 3 because j is equal to 2 is over, j will be 3. And the same when j will be 3, I will be from what? 2 and 1, I will be 2 and then I will 1 because I will be j minus 1, then I will be 1 and after that you will terminate. Now, you see in this case, while j will be 5, 5 is greater than key because key is equal to 4 here, hence 5 will be shifted. Now, 4 will become, again I will be 1, now 4 is A1 is 2, hence 4 is greater than 2, hence no more to shift, and now the loop will terminate because of the AI is greater than key, because I is equal to 1 and A1 is your 2 and your key is 4, hence the loop will terminate at I is equal to 1 because it is terminating not because I is greater than 0, but rather it is terminating AI is greater than key. Rather it is terminating due to AI is greater than key. That's why it will come out and AI plus 1, A2 will be key. A2 will be key means your A2 means A2 position 4 will be placed. Hence in this way, slowly it will go on inserting the position taking from the subarray which is not sorted one by one and putting in inserting in its the proper position of the sorted subarray. This is the method is called insertion sort. Okay, this is the insertion sort, because in the insertion sort what happens, the card in our hand, the subarray is already sorted and the cards which is placed in the table, suppose you are sorting the cards in ascending order, the cards placing in the table are not sorted, we are taking one by one and we are shifting the cards depending on the whether which one is greater than the card we have and we are inserting it. This method of sorting is called insertion sort, and this is the algorithm for insertion sort, and already you have also studied this algorithm in your data structure, just we are revising, but our main focus is to calculate the time complexity of this insertion sort. Now, in order to calculate the time complexity, now we have discussed in these slides you see insertion sort, we have to find what is the cost of each statement of this algorithm and how many times that particular statement will be executing. See, for j is equal to 2 to n. Suppose the cost of this because it is a condition checking, and I have already told in case of RAM model of computation, the primitive operations cost will be fixed and it is some fixed amount of time, and in that way we will calculate the time complexity or the complexity of an algorithm. And in that case, in primitive operation, you will be assumed to be some unit of time, some constant unit of time it will take. Hence, for j is equal to 2 to n, for this condition, what happens? I am taking C1 number of time for this condition checking for loop, and this for loop will run how many times? 2 to n. 2 to n times, because 2 to n is n minus 1, but in n plus 1 it will fail, but the condition will be checked. Hence, how many times it will run? It will run n times. Why not n minus 1 times? Because 2 to n, that means n minus 1 times the for loop is true, but for n plus 1 time the for loop is not true, it is false, but that time it has to check the condition. Since how many times the for loop will run? The for loop will run n times, out of which n minus 1 time is true and 1 time is false. Okay, hence if the particular for loop takes c1 times and the for loop will run n times, not n minus 1 times. The for loop will run n times, but out of this n times, n minus 1 times is true. That means n minus 1 time the for loop will, the control will enter to the inside of the for loop, and the last time it will come out of the for loop. Hence, for key is equal to aj. For do key is equal to aj. For this, we are assuming that c2 times, because inside the for loop will run, for loop condition will run n times, but inside the for loop, outer for loop, that is the for loop, all the statement will run n minus 1 times. Hence, do key is equal to aj. For this, the cost is c2, but it will run how many times? Because j will be 2 to n, j will be 2 to n. For this, the loop is 2 and it will come inside, hence it will run n minus 1 time. Now, next one, suppose this cost is 0 because actually it is a comment statement, and but it will run n minus 1, but this will not take no cost because it will actually, this statement is not executed inside the computer. Now, next is say it is taking cost is c4, it will also run n minus 1 times. Now, this will take c5. Now, the question is that how many, suppose the running of this while loop, how many cost of running of this while loop is c5, but how many times this loop will run? How many times this loop will run? See, this loop will run, it depends on the value of ai and key and the value of j, because I will be j minus 1 and it will come down to 0. Suppose for all the condition ai is greater than key, that means if forget the second condition, in the first condition if it is always true, up to how many times? Depending on the value of j. That means if it depends on the value of j, because I depends on j and j will be come to 0 only on depending on the I will come to 0 only on depending on the j. Hence, suppose the times it will be tj, it is representing tj. Why we are writing tj? We are writing tj because the number of times it will be t and it depends on j, because it depends on I and I depends on j. Okay, and this is the case. And now the next case, this is 6. If it runs j times, then the inside the while loop it will run tj minus 1 times. Tj minus 1 times. See, this c5 it runs tj times and j varies from 2 to n, because in that for loop j will be 2 to the n. That's why c5 is equal to times is equal to tj into j from 2 to n times. Because for j is equal to, the while loop will run, j is equal to 3, the while some iteration of while loop will come, for j is equal to 3, some iteration of the while loop come. Hence, that is tj or tj minus 1, they depends on j, and j, how many times j will run? In the first time, j will be 2 to n, j will be 2, and for this tj will run, for because for the outer for loop for j, the inner while loop will run. For outer for loop j is equal to, the inner for loop will be t 2 times. For outer for loop j is equal to 3, the t3 will times will happen like this. And this is the summation. Why this summation is taking? Because for different value of j, there will be a particular value of tj. And all the summation is the number of times that particular while loop will run. Similarly, for next case, c7 tj minus 1, j is equal to summation of j is equal to 2 to n, tj minus 1. And in the last case, c8, it will run how many times? It is out of the while loop, it will run your n minus 1 times. Like, because it is inside the for loop, it will run n minus 1 times. You see, it will run n minus 1 times. Okay. Hence, this is the case of the that means this is the cost of the algorithm in each step of the algorithm, and how many times that particular step will execute. Now, hence the time complexity Tn, the time complexity or the time complexity in this case, Tn is nothing but it is equal to C1n, all the cost into number of times, C1n, C2n minus 1, 0 into n minus, then you are forgetting because 0, and C4 into n minus 1, C5 into j from 2 to n, tj, like this. All the addition of this, all the cost and its corresponding into its times. This is the time complexity of the insertion sort. Hence, here tj is what? As I have already told, tj is the times, the number of times the while statement will execute at each iteration of j. and the j value will change from j2 to n. That's why Tj summation over j from 2 to n. Now this is the time complexity. Now we will analyze the insertion sort using this best case analysis. See, there are different cases already. Now what happens in the best case? In the best case means if the array is already sorted and we want to sort it. This is the best case. The array is already sorted and we want to sort it. In that case, what happens? Every time you take a card, no need to go further. We will put at the last. Suppose in the playing card, we want to sort it. Now we have some card in the sort. If the card is already given in sorted order, once we are taking it and putting it, next card we don't need to shift. We have to keep it. In the next card we will need to keep it. And in that case, what happens? In the while loop, how many times it will run? Because the while loop, we will not need to shift it. Hence, at the beginning, the AI is greater than key. That condition will be, the while loop will run only one time. While loop will run only one time. Hence, in that case, what happens? In case of C5, it will be, what happens? Because every times, you see, hence C1, in this case, what happens? Tj will be 1, because Tj will be 1. Because why Tj will be 1? Because Tj means for a particular value of particular iteration of for loop, the while loop will run only one time. Because while I is equal to 0 and ai is greater than key. This ai is greater than key condition, what happens? It will fail there. Once condition it will check and it will never go inside the loop. Hence Tj value is 1 and hence Tj minus 1 is 0. Hence the inside loop it will not go. Hence in that case Tn is equal to C1n plus, you see the value of Tn previously we have calculated. See, we have calculated. In that case what happens? We will put Tj is equal to 1. If we put Tj is equal to 1, then the C6 term will be cancelled out, C7 term will be cancelled out. Okay, hence C1 n, C2n minus plus C2n minus 1 plus C4n minus 1 plus C5, but Tj is 1. C5 Tj is equal to 1, j from 2 to n. Hence summation of 1 j from 2 to n is nothing but n minus 1. Hence C5 into n minus 1. Why C5 into n minus 1? Because C5 into summation of Tj, but Tj is equal to 1. Hence summation over 1 how many times? From 2 to n, that means n minus 1 times, hence C5 into n minus 1 plus C8 into n minus 1, because C8 into n minus 1 is already there. Hence it will be C1 plus C2 plus C4 plus C5 plus C8 into n plus C2 plus C4 plus C5 plus C8. But just a simplification, which is called an plus b. What is a? A is nothing but C1 plus C2 plus C4 plus C5 plus C8. Altogether we are saying it is summation of this A and summation of C2, C4, C5 and C8 is B. Hence it is equal to AN plus B. AN plus B. Hence it is equal to AN plus B means, as we have already said. So if Tn is equal to AN plus B, then it is theta of N. Theta of this is tight bound N, that means it is linear in time. Hence the time complexity or the best case analysis of insertion sort is theta of n. Insertion sort is theta of n. Now let us go to the worst case. In the worst case, what happens? If the card is or the number is reversely sorted, that means if the card is given and it is reversely sorted and we want to sort it, then every time we are taking the card, it will go at the end of the card in your hand. Then suppose you have something in the card and we are taking another card, then this card will go, because it is reverse sorted, everything in our hand is bigger than the card we are taking, hence we will shift all the cards in our hand and we will put at the end. Hence in the reverse sorted what happens? I will be your j minus 1, it will go to the end of the loop. That means in this case what happens? Our Tj will be j, because the while loop will run for all possible value of I that takes. That means I from j minus 1 to 0. That means your Tj will be j in this case. Are you getting my point? Because worst case scenario will happen. In best case what happens? The array is already sorted and we want to sort it. And in that case, at every instant of the while loop will terminate. The while loop will terminate. For every outer loop of for loop, while going to for the while loop, at each instant it will terminate. In this is happen in case of a best case. But in the worst case, the while loop will run all possible value of I, all possible value of I that I takes. Hence, in that case, that means I will go to the 0 starting from j minus 1. That means your Tj will be, in this case, Tj will be j. Tj, because Tj is what? How many times a particular, how many times the while loop will run for a particular iteration of the outer for loop. For a particular iteration of the outer for loop. Hence, if the outer for loop for a particular value of j, the outer for loop of j, then the inner while loop will run how many times? Tj times, and in that case, Tj will be j, because for whatever value of the outer for loop value of j, that much times the while loop run, because I will be j minus 1 to 0, j minus 1 to 0, because at that time, because the array is already reversely sorted. Hence, what will happen? The element we are taking, we have to take into the last end, because the reverse sorted means that means the card we are taking is already less than the all elements in our hand which is sorted. Hence, in this case, Tj will be j. If Tj will be j, then what will happen? In this case, you see summation of Tj j from 2 to n. Summation of j from 2 to n. That means summation of j from 2 to n. That means j is equal to 2 plus j is equal to 3 plus 3. That means it is summation of a natural number that is j from 1 to n. That is n into n plus 1 by 2. That means the summation will be n into n plus 1 by 2. Similarly, summation over j minus 1, j from 2 to n, it will be n into n minus 1 by 2. This is simple mathematics you already know. Hence, in that case, what happened? Tn is equal to C1n plus C2n minus 1 plus C4n minus 1 plus C5. In case of summation of Tj, what we have to Tj we have to write from j to 2 to n, we have to write n into n plus 1 by 2 minus 1 for plus C5 n to n minus 1 by 2. Like this, we have to write for C7 n into n minus 1 by 2 plus C8, it is n minus 1. This is nothing but simply the summation of j from 2 to n. This is n into n plus 1 by 2 minus 1. And summation of j from 2 to n, summation over Tj minus 1, it is n into n minus 1 by 2. Hence, this value we have put and we have put, and just by simply calculation of just rearranging n square term, n term and c, we will find that it is a into n square plus b into n plus c, because there will be some term of n square with some multiplication of c1, c2 like this, some constant, some term of some constant into n, and this is the theta of, what is theta of n square, because the tight boundary is here is n square, because n square is the upper, it provides the upper bound, and it also provides the lower bound. Okay. Hence, in the worst case analysis, the insertion, the time complexity of insertion sort is theta of n square. Hence, what is the advantage? These are good running time for almost sorted array. If the array is almost sorted, it is time complexity of theta of n. Disadvantage is that in the worst case scenario or the average case scenario, the time complexity theta of n square. In the best case, it is theta of n, but in the disadvantage is that in the worst case and average case we have not analyzed, but remember that in the average case and worst case we have analyzed is theta of n square. That means it is it is taking more time, and number of comparison and exchange, that means number of comparison and exchange will be n square by 2. Number of comparison and exchange at max it will be n square by 2. This is the analysis of we have discussed the insertion sort and analysis of insertion sort. Now I am ending the class here.